Hi Louisa. Right, this is number 5 of the probability non-calculator. Julian and Andrea taking this test. Okay, so this one is it's just a bit of a classic tree diagram problem, but they've just sort of thrown a few words in, so to make it look a bit harder than it is, but it's not really. That's working well so far. Oh, there we go. What's the delay? That's strange. All right, so it's like let's say Julian goes first, like that, and either he passes or fails, like that, and then after that, where are we? Then is it Andrea? And then Andrea goes next, and either she passes or fails, fails. And that fails. And the probability of Julian failing is 0.5, so if him passing must be also 0.5. And of Andrea failing is 0.6, so it must be 0.4. And it must be the same here, so 0.4 pass and 0.6. Okay, now it also then gives you this probability that they both fail as 0.3, but if you look at that, then 0.5 times 0.6, a half of 0.6, is going to be 0.3, so that sort of fits in with what we've already got. Now, what that's showing you is that, so we're saying, fail, first one fails and the second one fails, is 0.3. I think all it's saying there basically is that these things are independent of each other. It's, if one thing followed by the other thing together gives you 0.3. It gives you, then that means that Julian passing or failing has no effect on Andrea passing or failing. So from that point of view, then it's just an absolutely bog standard probability tree question, tree diagram question. So when it's saying at least one of them fails, well, these at least questions pretty much always, you flip them round. If at least one of them fails, it means they don't both pass. So if we can work out the probability of them both passing, pass, there's a bit of a delay on this, wait, and then a pass, would be those two times together, so 0.5 times 0.4 is. If the probability of them both passing is 0.2, the probability of at least one of them failing must be all the others, which must add to 0.8. So probability of, it's a bit of a hideous delay, at least one fail equals 0.8, and that's it. We're done. There we go. Right. So yeah, it's just a pretty standard question, but it's just got this extra bit here, and all this is telling you is that because these two times together give you this answer, give you 0.3, it just confirms that that these are independent events, that Julian passing or failing has no effect on